Welcome to using spreadsheets to manage and manipulate data. The goal of this tutorial is to have you come into class with a basic working knowledge of how to use spreadsheet programs to begin to work with your data. Within this tutorial, we have several different objectives. The first is that I'd like you to be able to learn how to open different file types in spreadsheet software and how to sort those data in order to identify key components. Second, you should be able to identify and troubleshoot cases when merged cells are causing sorting and analytical difficulties within a data set. This actually happens more often than you'd think. Third, you should be able to identify the basic layout of spreadsheet software, or spreadsheet data rather, in order to identify particular columns, rows, and cells of interest. You'll also learn within this program how to concatenate different cells in order to create a new index variable for working with your data. And you'll learn how to use formulas to work with and process data. Now, there are many different spreadsheet programs, from Microsoft Excel, which is really the current industry leader as far as spreadsheets, to OpenOffice, which is a free program. It's open source and it can be downloaded from Apache, to Google Sheets, which is freely available and works very similar to Microsoft Excel, but you can only use it online unless you're using the Google Chrome browser. But it is also free. To something like Numbers, which is a spreadsheet program created by Apple that can be purchased alone or as part of a package similar to the Microsoft Office suite. Now, these are spreadsheet programs. All the programs basically work in very similar ways. So in general, the nuts and bolts of how you accomplish a task will be approximately the same, but the different commands that you use are going to be based upon which version of a program and which program you choose to use. The examples I'm going to give you today will be using Microsoft Excel for Mac, but obviously it's going to be a little bit different on your computer. So you'll use the search terms that I'm showing you today to try to figure out how to do these things on the package or the spreadsheet program that you have available. One other thing to learn about spreadsheet programs is that they can accept many different file types. There are some super common file types like XLS files, which are Excel spreadsheet files. These are an older version of an Excel spreadsheet file that isn't used quite as often anymore. Most Excel programs or similar spreadsheet programs have been moved to using XLSX, which is sort of an open version of the XLS spreadsheet. This means that it can be opened in OpenOffice or in Excel or in any number of different programs. But then there's some really simple common file types that will be opened in Excel as well, or spreadsheet programs in general. These include comma-separated value files, or CSV. We'll use these a lot for data during this class. And tab-delimited text files, or .txt. Both of these are really good ways to store data so that the data can be read into other programs. We'll cover this more in class, but basically a number of the formatting options which are available in XLS and XLSS, or X rather, files aren't available in these two simpler file formats. So let's get started. All right, while most spreadsheet programs work well on a drag and drop basis, where you drag a file onto the program name to open it, you may encounter times when you need to open a file from within the program. This is particularly true when the file you're working with isn't initially recognized by your spreadsheet program. So an example of drag and drop might be that I could come to this .text file and I can drag it down here and drop it on top of my Microsoft Excel, and it'll open itself right up. So because it's a .text file, the program automatically recognizes the fact that each column in the data set is separated by a text character. However, if I wanted to open a more unusual file type, like this Nexus file here, which is a file format for genetic data, it's not going to look the same. There's not going to be the same number of breaks. In fact, what you see is that there aren't any column breaks in here at all. So I'm going to close it up and I'm going to open it. Don't save. I'm going to open it from within the program. And when I do that, it's going to give me a couple of options in terms of telling it how characters are delimited. And I can do that, and I can tell it that it should treat each space or every consecutive set of spaces as one, and that's going to give me the break that I'm looking for here between the name of the sequence and the sequence itself. And so even though some other parts of this file format may not be quite what I'm looking for, I've got this break in here, and this break is being recognized by the program, which will allow me to sort data, which is really all I'm looking for at this point. So let's go back to our main file here. So these data that you're seeing here are from a paper that deals with how sperm length relates to sexual competition within species. So you're looking at data for pheasants at the moment. And suppose we want to sort these data and see which pheasant has the longest sperm. We can do that pretty easily by going up to data, pulling down to sort, and telling it to sort by sperm length in micrometers. And let's see, it was actually already sorted this way, and what we see here is that the longest sperm turns out to be Germain's peacock pheasant, which is a species found in Indochina. And their sperm is, I suppose that's pretty long, 130 micrometers. So one of the things you're going to encounter a lot is that when you're sorting data, and we're going to open up another file for this, when you're sorting data, you'll occasionally get errors. If we wanted to sort these data, we can go to data and sort. We might sort by column ATD1 here. And we get an error that says this operation requires that merged cells be identically sized. This is going to happen a lot, particularly when you're downloading data from other places, which is a lot of what we're going to do in this class. We might look at our data set and look for merged cells. If we did that, we might see that this cell here, or right across here, this is all merged. So we'd go to merge and unmerge these cells. Then we would be able to sort these data. There we go. Now, if we have a lot of data, which we see here, it might be really hard to identify which cells are merged. So we'll go to data, sort. Oh, it won't sort because the cells are merged. So what we can do is we can select everything in our spreadsheet. We can do that by clicking up here on this arrow at the top corner. It's going to be a little different for each spreadsheet, but in general, if you click in this area of the spreadsheet, usually you can select everything. We'll go to merge, and we'll unmerge everything. Once we've unmerged everything, we can sort to our heart's content. So close this file out. Now, the basic layout of spreadsheets is going to be the same across most programs. So your data are going to be organized into columns. Those columns will be similar measurements across individuals. And your data will be organized into rows. Often these rows will be different pieces of data corresponding to the same event or individual. So what we see is that every cell, every piece within this data set is going to be referential. So what we're clicking on here is going to be E9. If we click down here, we are in F21. That's going to be important for when we put together formulas. You're going to find that you're often going to put together formulas because those formulas can allow you to do more with your data. Otherwise, we just work in a Word program. So one thing we might want to do here is we might want to analyze our data by a specific scientific name. Because if we analyze by genus, we'd see that there's more than one species in the same genus. If we analyze by species, we'd see that there's more than one species that shares the same specific epithet. So if we wanted to organize our data so that we had one variable, which would be scientific name, we might put these two things together. And we could do this by hand. We could just go ahead and type in Lofura and then space and Edward's eye and make a new column here that had that information in it. And actually, we're going to go ahead and make a new column to the left that has this information in it. We're going to call it scientific name. And we want to combine these two things in it. Now, when you've only got 24 items in your spreadsheet, it's pretty easy to go ahead and just sort of type them all out. But this is a lot faster if you do it this way. So what we're going to do is we're going to use a formula. And I'm going to tell Excel that I'm using a formula by typing in an equal sign. And then what I'm going to do is I'm going to type concatenate. And you'll see that Excel already begins to anticipate the fact that I'm going to use the concatenate formula, partly because I use it a lot. And so I've selected concatenate, and then I'm going to refer to each of the cells that I want to concatenate. In this case, I'm going to concatenate B2 and C2, and I can actually click on C2, but B2 is being covered up here. B2 and C2, and I'm going to hit enter. I'll double click up here to make this the right width, and what you see is I've got Lofura Edwardsi, but it's really hard to read because there's nothing in between these two cells. So I'm going to come back up into here, and I'm going to go ahead and add something in between. I could add a space, and you'll notice what I'm doing here as far as adding is I'm adding a comma, and then I've got parentheses around this space, and then another comma. When I do that, that gives us a comma right here. But because I'm going to be putting these data into another program, that space might not be read the same way by another program. Whereas if I put an underscore in there, that actually will be read the same way. So now I've got an underscore in between the material from, or the information from B2 and the information from C2. What I'd like to do now is actually have this formula continue on down. The way to do this is to go to the lower right corner of the cell, hold your cursor above that corner so that it forms a cross, and then drag all the way down. And that's going to fill all the cells below it with the exact same formula. And if you click on one of these cells, you'll see that you can actually determine which cells it's referring to. So in this case, it's referring to B11 and C11. Again, this is a simple spreadsheet, so it should be pretty straightforward, but when you get to the point where you're dealing with lots and lots of data, it's really nice to be able to see what your formula is referring to. So the last thing I'm going to do here is I'm going to create an index. This index is going to be something where we're going to actually do some calculations using the other data. So what we have here is we've got male body mass and male sperm length, and spur length rather. So this is the spur like a turkey has on the back of its foot. And what we might want to know is how that spur length relates to body mass. Because if you imagine an animal like a bird or a pheasant that has a spur, larger animals can have larger spurs. So how unusual is this spur size given the body mass? So we'll call it spur.index. And what we're going to do here is we're just going to go ahead and take spur length and divide it by male body mass, and we're going to hit enter, and that's going to do that calculation. And just like before, we're going to go ahead and populate these cells below us with that information. So we've created an index here out of two measurements. One of the things you see is that in this case, we've got nothing for spur length for this species, but we do have a body mass. And that means we're actually getting 0 out because nothing divided by something is 0. What we really want to do is we want to make this an NA. For looking at these data within Excel, it doesn't make a difference, but if we wanted to read these data into some sort of statistical package like R, what we'd find is that it would treat those zeros as actual zeros, and that's going to be a problem. So we're going to fill those as NA, and we might just want to go ahead and sort by this new spur index. When we do that, we're going to find that the largest spur, given the body size, actually belongs to Gallus gallus, which is the wild relative of the domestic chicken. So that should give you a bit of a basic background in spreadsheet usage. We'll cover more on this topic in class. If you've got a particular set of things that you need to learn or are interested in learning how to do, let me know and we'll try to cover those things in class.